Hello from ABIOTEQ. So today we are going to talk about ACD 10 sensor, which is used for measuring carbon dioxide levels in parts per million. And this is how the sensor looks like. And this is how the connection is. Pins 5 and 6 are not used because the software code that I'm using, the library doesn't make use of it. Although there are methods to communicate those pin values through some other protocol. Right now I'm using I2C protocol, which makes use of SDA and SCL. DA for data, CL for clock. The SDA is pin number 1, which has to of the sensor, which has to be connected to this is analog 4, A4, and then SCL is a clock pin of the sensor that needs to be connected to A5, analog 5, and it has an inbuilt pull-up resistor which takes care of the current not going too high for a 5 volt supply, as we can see. Okay, so ground and a 5 volt supply are the blue pin, which is the SCL is connected to A5, as I told you earlier, and then the third one, which is the red, the brownish orangish one, that goes to the ground, and the blue wire, as you can see, is as I told you earlier, and the green wire, yes, the green wire, which is the last one, is the one which is giving 5 volt supply. Under these conditions, the pull-up resistors, which are inbuilt, works very well and doesn't make the current go too high to spoil the devices inside. And then we have the printer cable connecting to the USB through giving the power supply, and also connection to the IDE, Integrated Development Environment, where I'm going to show you the code, and this is the code where I'm calling the library ACD10 and wire.h. A baud rate of 9600 is fine, and then I call the objects and their functions, get carbon dioxide concentration, and also get temperature values, and then I print it out by a tab. Okay, so this is the code for it, and I verify my code, like compilation and stuff. It happens pretty well. Done compilation, as you can see. I don't know whether if you can see it or not. Yeah, done compilation. And then I upload the code to my Arduino board. The upload has happened successfully, as you can see the dotted line, and it tells me the readings immediately. Although it takes about 2 minutes to heat, but since I had already heated up my sensor, it's fine. So the value of the carbon dioxide concentration is about 1351 in ambient air in Delhi. It's more specifically in Chhatarpur area in Delhi. So this is how the carbon dioxide concentration. It is pretty high compared to what normal values are. This is actually quite high. Normal carbon dioxide value is about 0.04% in a normal area, but in Delhi it is coming out to be 0.13%. This is pretty high, because you have to divide this number by 10 to the power 6 to get the parts per million, and then multiply by 100, so that becomes 0.13%. It's pretty high compared to normal value of 0.04 carbon dioxide that usually is being said in textbooks and also in Google. So the second value is the temperature, and I don't care much about it because the calibration of this is not mentioned what actually this is. So now what I'm going to do, as your representative from ABIOTEQ, is that I'm going to breathe some fresh air and then hold it in my lungs and then blow it to the sensor. This way there will be a supply of carbon dioxide to the sensor, and the values are going to change. So until the values don't change, until I do this, you can maybe see this plot of the two values. The value 1 is what we care. So it's a straight line that I'm getting at about 1300. Yeah. So just keep watching, and I'm going to breathe air and blow it to the sensor. Okay, so now I have blown into the sensor and see how the plot is going to change with time. The x-axis is the time and the y-axis is the concentration level, and you can see that the values are rising. The values are rising and rising because the carbon dioxide that I exhaled into the sensor or around the regions of the sensor is going to get inside the sensor, and the values are going to go up, and I guess it's going to cross 4,000 parts per million. Yeah, it's crossing, as you can see in the graph. It's going to go up, and it has crossed 0.5. It has reached even 6,000, as you can see, 6,000 parts per million, and then it becomes a straight line because now the ambient air is going to get inside the sensor, and this is like how the plot went up. The ambient air is going to get back to the sensor, and the curve is probably now, since it's now stagnant, which is a straight line, it's now going to go down. You'll see it very soon, because it's essentially a chemical reaction which is happening. So the carbon dioxide that I blew into the sensor went inside it, it stayed there for a time, and then the ambient air is going to come back into the sensor, and you can see now the drop has started to happen. The levels of carbon dioxide is going to be lower, and it will be 2000. It will come back to 1300, I'm assuming, and that is what the carbon dioxide level is in South Delhi region, in South Delhi region, of course. Notice that the red line remains the same. The temperature is not much affected. Okay, so now it's going well below 2000, below 2000. Yeah, here's the y-axis. And I think I should now shut off the video, because I have now demonstrated how the sensor is going to work. Although if I wait a little bit longer, it can drop a little bit more. But I think if it is dropped below 2000, that's where it started from. So ACD sensor demonstration is over, and we have demonstrated very successfully that for a small increase in carbon dioxide, this sensor with this Arduino microprocessor, robotic programming or electronic programming, we have been able to show how it works. So this is the code once again for those who want it again. Thank you for your time, and hope you enjoyed the video. See, the levels have gone to 1362, in the range of 1300, as I told you earlier. So bye bye from ABIOTEQ. Hope you enjoyed the ACD 10 sensor programming, electronics programming.